Hello everyone. In this video, we're going to be solving a Sangaku puzzle. According to Wikipedia, Sangaku puzzles are Japanese geometrical problems or theorems on wooden tablets which were placed as offerings at Shinto shrines or Buddhist temples. So here we go. We have a unit circle, a square, and an equilateral triangle that are inscribed in a right triangle as shown. Find the side lengths of the square and the equilateral triangle. So, the only thing we know about this puzzle is that the radius of the circle is 1. And then using that information, we're going to be able to find the side lengths of the square and the equilateral triangle. So here's how we go. I'm going to be making some connections, obviously, right? That's unavoidable. So let's go ahead and mark the radius here. And then, of course, we can mark it here as well. Right? Now, one thing to note here is that if I connect this point to that point, the center is going to go, basically, the segment here is going to go through the center, right? Because you have some congruent triangles here. You can also make this connection, another radii, right? And then this one as well. Okay, awesome. Now, we know that the radius of the circle is 1. So this is going to be 1 and 1. That's pretty much what we're going to use to find all the other lengths. Okay. Now, what do we know about the other pieces? Well, first of all, one thing to note here is that you have an equilateral triangle. So this is a 60-degree angle. That also forces this to be a 60-degree angle and a 60-degree angle here as well. Great. Now, when you consider this, obviously that's a square, so that's a 90-degree angle. This leaves us a 30-degree angle here and a 30-degree angle here. So basically what we're dealing with here is an equilateral triangle and an isosceles triangle. So these lengths are also congruent as well as these lengths. Awesome. And you notice that there's a 30, 60, 90 triangle. So this formation basically forces this right triangle to be a 30, 60, and 90 triangle. There's no other way this is going to work. Okay, so this is also 30 degrees. Now let's see how we can use this information. Now I know that this is 1 and this is 1 as well. Now here's the critical part. Since I know that these are, 30, 60 and 30, 60 degree triangles, I also basically know that this is going to be a 60-degree angle. So if you split it out in half, these are going to be 30 degrees. That's a right angle. That's a right angle. So we do get another 36. Actually, we're getting a lot of 36 to 90 triangles here, by the way. But let's just consider some of them. So since this is 1, that's the shorter leg. The longer leg here is going to be √3, and this is 1. All right? This is 1. And this is going to be, in this case, since this is a 30-degree angle, this is going to be the shorter leg. So to find the shorter leg from the longer leg, you have to divide by √3. And if you divide 1 by √3, you should be getting something like √3/3 for that little piece there. And that's also critical because we need this length. Okay, cool. So I know that length. What else do I know? Well, you should also know a couple other things, but let's go ahead and proceed with this one. So let me go ahead and drop a perpendicular here, which is the height, right? I'm not sure if that's the midpoint, but I just I guess that's where I marked the, congruent segments. But let me go ahead and just drop a perpendicular here. Hopefully that's going to be good. Okay, great. So now I do have that, this little piece is here, √3/3 as well, and this is 1. So basically what I get from here is that this piece is going to be 1 plus √3, and this piece is also going to be 1 plus √3. Okay, great. Now let me go ahead and drop another perpendicular segment here, right? And this is another 30, 60, 90 triangle, which is critical because what I have now is that I know that this is 1 plus √3, so I can basically find this because I know that the hypotenuse is 1 plus √3, and this is just going to be half of that, right? Okay, so since, did I say √3? Okay, so it's √3/3 plus 1. That's basically what I'm talking about. So if you calculate that, so √3 plus 1 over, okay, let me just fix this. So it's going to be √3/3 plus 1, which can be written as 3 plus √3/3. This piece right here, okay? And then I'm talking about this piece and that piece, here and here. Okay, So what I need is half of that. So if you cut that in half, it's going to be 3 plus root 3 over 6. So this piece is going to be 3 plus root 3 over 6 here. Great. Okay. Now, I know that piece, right? And I just need to find more lengths here. So here's one thing to note, that since this is like root 3 plus 1, this is also going to be root 3 plus 1. So that's critical because we do have congruent triangles here, and that's very important because now this gives us the side length of the square, basically, right? So the side length for the square is root 3 plus 1. We found it already. Great. Okay, now what I gotta do next is finding the side length for the equilateral triangle. So I don't think I'm gonna need that piece, so let me go ahead and erase that area. Let me clean it up and maybe use some other colors like this one. Okay, great. Now, what am I gonna do next? Well, I can also get rid of this, I guess. I don't think I'm gonna need it. I needed to draw the picture to get the coordinates right because you have to calculate it beforehand, right? All the points, all the coordinates, but I don't think I'm gonna need it for my calculations. Okay, cool. Now, what I need to know is the side length for the equilateral. And if you notice that we do know actually the hypotenuse of this right triangle here. Let me go ahead and shade that for you. All right. We know the hypotenuse is root 3 over 3 plus 1 plus root 3 plus 1. Let's go ahead and add them up. So the hypotenuse is root 3 over 3 plus 1 plus root 3 plus 1. Okay, I could write it as plus 2, but anyways, no problem. So what I need to do here is basically make a common denominator, just simplify this as much as I can. So I'll get a 3 root 3 from here. I'll get a 2 times 3, which is 6. So it's going to be like 6 plus, right? Then I should be getting something like 4 root 3 divided by 3. So that's basically going to be the length. That's going to be the length for the hypotenuse of this triangle. But that also gives me what? The side length for the equilateral. So the side length for the equilateral triangle is basically going to be 6 plus root 3, 4 root 3. Let's back up a little bit. 4 root 3 over 3. And the side length for the square is going to be root 3 plus 1. For the square, basically, the side length is root 3 plus 1. For the equilateral triangle, the side length is 6 plus 4 root 3 over 3. And that brings us to the end of this video. Thank you for watching. I hope you enjoyed the video. Let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, take care, be safe, and bye-bye.